All right, final exam cheat sheet. In this series of recordings, I'm going to be covering every single question you're going to find on your second semester final exam. I'll go question by question. I will point out a couple of the consistencies with the other test preparation recordings I've done. Namely, I will be indexing each of the problems with a chapter and section reference. So for instance, our very first problem is going to come from chapter 1, section 6. This just allows you to check your notes for key terms, other example problems, any other information you might need, helps direct that search. All right, I'll show you a basic structure of the problem you're going to see. Problem number 1 on your final exam will not look exactly like this because the numbers will be different, but it'll be the basic structure. So I'll also be showing you how to interpret what you will ultimately see on your final compared to the example we'll run through. All right, so there are 18 questions in your final exam. Let's run through for the first question right now. All right, question number 1, you're going to be given what's called an exponential function, basically the title of this very section. An exponential function, the signature here is the fact that I have a variable, x, up here in the exponent spot. And so you're going to see an equation like this. Again, the numbers will be different here. And this question will have an A, B, and C element. A and B are simply just going to be identifying a number and doing a quick piece of arithmetic to solve an answer, so they'll actually be very fast. So let's jump right in. All right, part A. The very first thing you're going to be asked to do with whatever exponential function you are given is you're going to be asked to determine whether or not the function represents growth or decay. The equivalent of this with like linear equations would be asking whether or not it had a positive slope or a negative slope. Basically, is it growing over time or is it shrinking over time? And so in this case, I'm simply analyzing one number. It's going to be the base of the exponent. It will be in parentheses like you see here on your final exam, but it's going to be the number that's beneath the x in the exponent. This value will determine whether or not it's growth or decay. So this 1.16 is what I'm analyzing. Essentially on your final exam, just looking for the single answer of is it growth or is it decay? The work here is just basically looking at the number and figuring out is it bigger than 1 or less than 1? Quite obviously, 1.16 is bigger than 1. Because it's bigger than 1, this function is growing over time. An example of decay, be prepared for either. If you had some, for instance, instead like 0.94. 0.94 is obviously less than 1. That would be an example of decay. It'd be shrinking over time. Simple enough. All right, part B. All right, we've already established that this function is growing. It's increasing over time, simply because that base of the exponent, 1.16, is bigger than 1. So the next follow-up question would be, well, how fast is it growing? And we call this this value a rate of growth in this case. Had it been decay, it would simply be a rate of decay. How fast would it be shrinking? And so again, I'm going to be analyzing the same number. So I'm still going to be dealing with this 1.16 in this example because it's the base of my exponent. But what I'm going to be doing here with that value is I'm going to be subtracting 1. If you want to understand why we're subtracting 1, you can go back to the section 6 notes from chapter 1. Essentially, we're just finding out how far away from just staying the same is it going to be. So the 1 value for a base and exponent would basically mean that it's staying constant. Anything changed from 1, whether it's more than or less than, would decide how fast it's changing. So essentially, this is just a quick step on your calculator. Take that base of your exponent, whatever value it may be, and subtract 1. If this had been a decay function, then you're going to end up with a negative value. That's okay. The negative would just confirm the fact that it's decaying or shrinking over time. In this case, because it's growing, you will have a positive result. Just do the step on the calculator. Trust the calculator result. 0.16. All right. This is basically how fast it's changing. We have found the rate of growth, but we're going to change this into a percent to make it maybe a little bit more familiar to us. So anytime I convert a decimal into a percent, I'm taking that decimal and moving it to the right twice. So 0.16 becomes 16%. To be a little bit more specific, this is 16% growth. That is how fast this function is changing over time. It's growing by 16% every time I'm measuring it. Okay, again, just to emphasize, had this been decay, this value would have been negative. So for instance, if I had a 0.94 base of my exponent, if I subtracted 1 from that, I'd get negative 0.06. That negative just confirms that it's decay. And if I move the decimal twice, 0.06 would turn into 6% single digit decay in that case. All right, but again, these both A and B just dealt with interpreting something from that initial equation. Part C is going to involve taking an action of plugging something in or substituting. You will be given an X value. For the sake of this example, I'll just pick one, 4.29. Okay, this was actually pulled directly from our first semester final, so that's what these numbers come from. Again, your value will be different on your final exam, but you'll be given some X value. And you're going to be asked to basically solve for the other variable, in this case, y. So essentially, this just becomes a substitution problem. So just to rewrite the function, my function here is y equals 320 times 1.16 to the x power. Now, since I've just been told what x equals, I'm going to be substituting this value into that exponent. And it's important to understand that that's an exponent, it is not multiplication. So this 4.29 comes directly from whatever value I was given. And now this just becomes calculator work. The same would be true if I had been given a y value. It just becomes a little trickier because doing the inverse functions to solve for a variable in the exponent is higher level mathematics. In this case, this just becomes calculator work. So at this point, because it's just calculator work, I just have to be careful of order of operations. Order of operations dictates that I do the exponent first. So a common mistake, people would multiply these two together and then try and send it to the 4.29 power. Again, I need to do this first because of order of operations. So just pointing this out on a calculator again, I've done this a couple of times throughout the class, but all of our calculators will have this button right here, x to the y power. This button right here allows us to customize an exponent. So for instance, when I'm doing 1.16 to the 4.29 power, I would start with the base of my exponent, whatever value I had here in my final exam. And I'm going to press this button right here. Nothing happened yet because now it's waiting for this exponent value. In this case, 4.29 equals, it's a gross decimal, not unexpected given the values I have here. Be aware that on your final exam, it won't be something you can do in your head, much like this. So this result, I'm going to hang on to it into my calculator right now, because there is one last step I have to do here. I do need to multiply this result by that leading value, that 320. So this 1.16 to the 4.29 power gave me this result. I'm going to multiply that by that 320 right there. Again, your number will be different on your final exam, and this is my result. You'll be asked to round it to 2 decimal places. So just doing that to finish this off, y is going to be approximately 604.89. And part C right there, again, this is basically just substituting in some value for x, doing the calculator work to solve for y. There's problem number 1 on your final exam. All right, let's move on. Problem number 2 is going to come from chapter 2. These first several problems in your final exam will be referenced from first semester. And this one will be from chapter 2, section 2. Chapter 2 introduced polynomials, and section 2 specifically focused on multiplying those polynomials. Something we've actually done several times throughout this year, but here's an example of what you will see. Again, the numbers are subject to change on your actual final, so this is just an example of what we're going to be seeing. So you're going to be asked to multiply 2 polynomials. You will have a binomial, 2-term polynomial here at the front, and a 3-term polynomial here that's being multiplied by. Essentially, this breaks down to 2 steps. First, I'm going to take each of these objects in my first parentheses and multiply them throughout the next parentheses. It's a process called distribution, something we're actually very familiar with for a long time. Once I've distributed, I'm going to end up with a long sentence polynomial. When I have that result, then I'm going to collect like terms to get basically a more condensed or simplified version of that. All right, let's jump right in. So my first object here in my first parentheses is x, positive 1x to be a little bit more specific. And because it's multiplication, I'm going to multiply that x by each of these terms throughout this next parentheses. So I'll use blue to represent multiplying x by each of these guys. All right, so just be careful with this. X times 2x squared. X times 2x squared will give me 2x to the third power. Positive x times positive 4x gives me positive 4x squared. Positive x times positive 3 gives me positive 3x. Makes sense that I got three terms because I multiplied x by each of these three guys. Those are the three results. Done with the x value. All right, now I'll use pink to represent the next object. Be careful here, a sign. This negative sign is attached to that 3. So my second object here is this negative 3. And again, I'm going to multiply it throughout this next parentheses, each of those objects. So I should end up with 3 results. Negative 3 times positive 2x squared gives me negative 6x squared. Negative 3 times positive 4x gives me negative 12x. And lastly, negative 3 times positive 3 gives me negative 9. So I finished distribution. Again, just take each of the objects that you have and you're multiplying them throughout the parentheses. You will end up with a long sentence polynomial that we see here. At this point, now I need to condense it down or simplify it, collecting like terms. And here's where we need to be careful. I see this mistake a lot. People think that we need to keep multiplying. That's not true. Now I'm just dealing with the arithmetic, addition or subtraction. The signs will matter, so I'll make sure I keep track of that. But now I'm going to be writing my final result by collecting like terms. So like terms here will be x to the third powers can only combine with other x to the third powers. Well, since there are no other x to the third powers, this positive 2x to the third stays exactly that. Just as a suggestion, you don't have to do this, but as I condense these down, I eliminate them as I make my way through them. There was only the single term, so there was nothing else to eliminate. The reason why is just because this is a lot of terms, and it's pretty common for students to kind of leave one or two behind because they're moving too fast. This is just a quick way to check it. All right, let's keep collecting like terms. So I'm done with my x to the third powers. I have an x to the second power, or x squared. That can only combine with other x squareds. This guy is also an x squared. So positive 4x squared minus 6x squared gives me minus 2x squared. That positive 4 and negative 6 combine to make that negative 2. Again, x squareds can only combine with x squareds to give me an x squared result. So got through those guys. Moving my way down. Now I'm on to single x's. X's can only combine with other x's, so positive 3x can combine with negative 12x to make negative 9x. Done with those guys. And at this point, there's a single term left over. Numbers can only combine with no other numbers, so the minus 9 stays minus 9. Cross it out at that point. But now we've combined all our like terms. We have officially condensed it down to a single phrase. Your result on problem number 2 on your final exam will look similar to this. It will end up being a 4-term polynomial like this, as long as actually nothing is eliminated. So it is possible for instance, like if I had 4x squared and negative 4x squared, that they just cancel and there's just 0x squareds left over. I obviously don't need to write 0x squared. It would just be eliminated. So that can happen. But again, breaks down to distribution and collection of like terms. There's problem number 2 on your final exam.